Hello everyone, this is Antonio and I'm going to give a demo of a tool that we have developed between the University of York and Aston University called HUNK. HUNK is an open source project which is part of the Eclipse Foundation, and it specializes on indexing large models. Over the years we have accumulated different resources teaching about how to use HUNK and what HUNK is for. In particular, to introduce HUNK, I will be using some of the slides that we used in a tutorial that was given at Models 2018 about dealing with very large models using HUNK for indexing and NeoEMF for storage. The basic idea with HUNK is, say that you have a very large model that you're keeping in some kind of version control system like Git or Subversion, way back when, and you wanted to run a query over such a model. If you wanted to do that, you would normally have to check out and load every fragment of the module and then run the query. And potentially that could end up using all the memory that you had or even more, right? So you would be limited in the size of the models that you can query over based on the memory of your development machine. The idea with HUNK is instead we take each of those fragments and we reconstruct a graph database from the different fragments that we connect together. And when you want to run a query, then you can just query that graph database instead of having to go and reload the whole module in there. You do not have to check out and download the module. You can just ask HUNK as a service of the network as well. There are several ways in which HUNK can be used. HUNK can be used as an Eclipse plugin, as a Java library, or as a network service. HUNK has a component-based architecture, which means that there is a core that is reused by everything and that glues everything. That is the incremental graph update algorithm and a set of generic interfaces. And then you can add different implementations for those interfaces. You can have different backends supporting a variety of graph databases. So there are some for Neo4j, there is one for ORMDB, there is one for GreyCat, and more recently there has been one added for SQLite as well. Then you can also support different clients. So for instance, we have an Eclipse graphical user interface, which is the one that we'll be using for this demo. We also have a set of Apache Thrift web services, which in fact can be used from the Eclipse UI. So from Eclipse, you can use a remote Eclipse HUNK server running in a different machine. Then when you have the models indexed, you can query them through different languages. And then we can also support different kinds of model parsers. We are not limited to EMF models. So for instance, we also support Modelio models. We can load, say, things like Eclipse plugin manifests as models as well. So here's an example of how HUNK works before we go into the actual tool. We have a library1xmi model file that is conforming to the library.ecore metamodel. So say we have a book titled B1 written by author A1, and those conform to an author type and a book type within a library metamodel. And it is that we go from those model files into a HUNK index, into a NoSQL graph database. And the idea is that an ecore package becomes a metamodel node, an ecore class becomes a type node, then each file becomes a file node, and each model element becomes an element node. And we also keep some internal indices inside that graph database. So we have an index that goes from the package URI to the metamodel node, and we have an index that goes from the file path to the file node as well. And these sort of help to get the query started, essentially. But additionally, we can define custom indices by an attribute or by an expression, which means that we could, for instance, quickly find books by the first letter of the author, for instance, or we could find authors by the number of books they have written. And this is it for the general introduction of the idea of HUNK. Just before I go into the hands-on demo, just wanted to mention that if you would like to download and try out HUNK, you can always go to eclipse.org/HUNK. And now we'll do a hands-on demo of Eclipse HUNK. Everything that you need for Eclipse HUNK is available from the official website. In this case, what I'll be using is the HUNK server that you can download from this fileable friendly artifacts section. And I will also be using an installation of Eclipse that already has the HUNK plugins installed as well for the latest stable version at this time, which is 2.10. So first I will download the server. So I've got the server running now, and now I can switch to Eclipse and we can start indexing things. So in order to index models with HUNK, the first thing that we need to do is we need to create what's called an instance, and that's a particular index for HUNK, for a collection of models. So in this case, let's say that we're going to call it the JDT set1 index, and it's going to be a thrift-based remote HUNK, so it's going to be running in that server that we just started, and we're going to be using the default updater, which only keeps the latest version. We could have used one that kept the whole history of the model, but that's for a different demo if you're interested. And we could use different backends. So in this case, we'll use the GRECAD one, which allows us to both produce temporary models or just keep the latest version as well. You can specify a minimum and maximum delay for the periodic checks that HUNK does on the model storage locations. You can also enter 00 to just disable that. So I will not be changing the models in this demo, which is why I'm going to be disabling that behavior. And in that case, I have to manually tell HUNK to check again the repository. Now I can go into the advanced tab and I can pick exactly which components I want. So I want the EMF metamodel resource factory. So HUNK understands EMF metamodels. I want HUNK to understand EMF models. And I want to turn on the EOL query engine. Then if I click on finish, it created that instance in the server. So the first thing we need to do is we need to tell HUNK about the metamodels that our models are going to be conforming to. So we can just pull those files from the workspace. So I double clicked on the JDT set1 entry to open this configuration dialog. And I go now into the metamodels tab and I click on add from workspace. And from there, I'm going to pick these 3 metamodels because I know that the models I'm going to be indexing conform to that. They're going to be models from produced by reverse engineering Java code. Those are now added to the graph database. And now I can tell HUNK about the location I want to index. In this case, I will index a particular folder in my system. And specifically, we're going to index the set1 module. This folder has XML files and so on, so HUNK will essentially find those and mirror those into the graph database. So now it's updating. We need to wait for a bit. So now HUNK has finished. It took some time. This is mostly because first there's a bit of warm-up for the JVM, and GRECAD is not necessarily the fastest one. The main advantage of the GRECAD backend is that it allows us to record the whole history of a model into a temporal graph. But if we have larger models, we usually go with other backends, such as the Neo4j1 or the SQLite one. Now what we can do is, instead of having to load this file, we can run these different EOL queries directly on the model. So say, for instance, that we wanted to find all the singletons in this Java module. And to do that, we have written this bit of EOL, which basically goes through all the type declarations. And then for each of those, it tries to look into the body declarations, and then it goes into the method declarations, and it's trying to essentially find the getInstance method that usually goes with implementation of the singleton design pattern. So it has to be a method whose return type is the type that is defining that method, and it should also be a public and static method. So if I wanted to run that query, I would click on this magnifying glass icon, say that I want to run the query in the current editor, and then I would run the query. It takes a little bit of time, and then I get my answer here. Again, this query is running straight on the server, and this is a thrift structure that can be used from different places. So these can be used from Python, from JavaScript, from all kinds of different languages. And there are many options to control the scope of the query based on the paths of the files, based on the underlying tree-like structure of the module. we can provide default namespaces for the queries, and we can define different traversal strategies for the model as well, but there's not enough time for this. So this is one query that we could run. Obviously, this takes some time. Of course, the next time we run it, it's very fast because we basically keeping this modeling in memory, and we can keep querying this. But you did see that the first time it ran, it took about 2 seconds. So if we wanted to speed this up, there are different ways we could do this. We can essentially index in advance certain model elements to find them through a value of an attribute or a value of an expression. And let's try adding some things. So for instance, one thing we could do is we could index method declarations by whether they were public, by whether they were static, and by whether they were returning an instance of the defining class. So to do that, what we do is we again go into that configuration section by double clicking on the index entry on the instance, and then I go into the derived attributes section, go to add, select the meta model. So in this case, I know it's the DOM meta model. Select the type, and again, we know that it's the method declaration type. And then we have the attribute type. In this case, it's a Boolean. These options are not relevant for this at this moment. And now we're going to load that expression. So I want to index the method declarations by whether they're public. And I'm going to call this is public. So this is going to extend all method declarations with a new attribute, which is automatically computed through this expression. And I click on OK. And that is done for the method declaration type. I'm going to be doing that as well for the static attribute. And then we're going to add another one. And I add that as well. So with these, we can essentially find very quickly a method declaration by whether it's public, it's the same return type, or it's static. I'm also going to add this one, type declaration is singleton. Just as an example of different strategies we can take when we define these derived attributes. Now that's done. And now what we're going to do is try running some queries. So this was the original singletons query. Now, if we have the derived attributes on the methods, we can simplify this query because we already have the additional isPublic, isStatic, and isSameReturnType attributes. So we can just run this query like this. And you notice that it took much less time to run even for for the first time. The way this is written, it's using those pre-computed attributes, but it's not speeding up the lookup of the location of these method declarations. So I'm still going through all the type declarations, all the body declarations, their method declarations, and then checking things. But instead we can flip the query on its head. We can first find the methods in question, and these, if we do it this way, HUNK is smart enough to change this to a lookup automatically, and then from there we go on to find the types that contain these methods. So if we do that, this is going to be slightly faster as well, so that was 32 milliseconds. And if instead we turn this into a straight lookup, I just want to directly find the singletons, then I can also run that, and you'll notice that that is even faster. And if I rerun it, it's even faster. Now this is some jitter as usual, but generally it's going to be the fastest option. Of course, this is up to us. We can define those derived attributes in a more specific or less specific way, but this is essentially what can be done with HUNK. We have various extensions for supporting different modeling technologies. We also support derived edges, so derived references and not just derived attributes. We can index the whole history of a model, and we can traverse through that history as well. But perhaps that is for another demo. Thank you for watching this demo.